Right, so part A, find the area of R. We're given the equations for both of those curves that we see are lying on the curve. If we're going to do this dx, we're going to go top curve minus bottom curve. If we're going to go dy, we'll go right minus left. As far as dx or dy, you're already given these equations in the form y equals, which actually is kind of weird, because that means you want to do it which way? Dx, yeah. So limits of integration, what axis do they come from? Dx. Go top minus bottom, so what's your top? Bottom. Okay, now they want to find the area of R. We've set it out, and we don't have a calculator, so we'll go down a page, and let's put in the work that's necessary to find it. Antiderivative of 2x. X cubed minus x cubed over 3, evaluated from 0 to 2. So we are 2 squared. Take away how much? 0. This is like a big F of A minus big F of A. 2 is your B and 0 is your A. So we simplify that. 2 squared is 8. 2 cubed is, no, 2 squared is 4. 2 cubed is, so 4 minus 8 thirds, 4 thirds. Last sign, right 4 is 12 thirds. Yep, 4 thirds, that's what we're looking for. And we'll go back and check the answer here in just a little bit. So now we go to part B. The region R is the base of a solid. For this solid, at each x, the cross section has an area of A of x. Find the volume. So we're perpendicular to what axis? Okay. So is this dx? So limits of integration are? Okay. What do I plug in? What's my integrand? So we set it up but haven't evaluated it. So now we'll go down. There's the work for A. Okay. So you don't have a calculator, so the most difficult part is going to be the anti-differentiation. So you can go use substitution, you could go formal or not formal. So here it is formula, u equals, what's u? Pi over 2x. What's du equal to? What's the derivative of 5x with respect to x? 5, yeah, so the derivative of pi over 2x, just another constant, is going to be pi over 2. So we got the dx over here. That dx is showing up, remember it was like du dx equals pi over 2, and we can multiply both sides by dx. Okay, so now we want to make our substitutions. We've got u, now du. We don't have du, so what are we missing? The pi halves. I'll put in the pi halves. So what do I have to put up front? 2 over pi. So we write this. So you got 2 over pi times that's about now we can make our lives easier here. This is kind of that last component of u substitution, the last fine detail. I'm not going to go back and write on 2 and 0. I need to do something to these before I put them back in as my limit. Plug them into so u is pi over 2x. Okay. So plugging 2 in, you get pi over 2 times 2 is pi. Okay, so this is plug 0 in, so you got pi over 2 times 0, and you get 0. So that's nice. So we've got 2 over pi. I don't really know the antiderivative of sine u with respect to u. Get some. So you got 2 over pi times, big F of b minus big F of a. So negative cosine pi minus negative cosine 0. Alright, cosine of pi. What's the x-coordinate at pi? Negative 1.
The coordinate factor is pi.
So, but it's a negative cosine pi, so a negative negative 1. Positive 1. And we're going to take away, well, what's the cosine of 0? 1, so that's 1. So we got a minus 1, so plus 1. So our final answer is 2 over pi. Our next the final answer times 2, which is 4 over pi. So we'll go back in the end and we'll check our answer. Okay, part C. Almost there. Alright, another solid has the same base R. For this solid, the cross-sections perpendicular to the y-axis are squares. Write but do not evaluate an integral expression. Limits of integration. Generally speaking, what did we say the shape was? Squares, so I'm saying the formula for a square is like length squared. Do this line perpendicular to the y-axis because this is dy of squares coming out of here like this. So can anybody tell me the side length of one of these squares that exists in here? How do we? Jake says 2x minus x squared. You guys agree? Rewrite it, okay. So you said y equals... No, that'll work. Are we all okay with that distance that I drew in? Okay. Anyway, yeah, now you're saying, oh, it's dy, I need this slope. I need to have it in form x equals. The ordered pair that sits out here at that dot, that's obviously x comma y. The length of that black line, is that all about the x coordinate there or the y coordinate there? That's a horizontal distance, that's about the x coordinate. The length but is its length about the x or the y? Yeah. So, one way to describe the x coordinate is with x. Right? But can we rewrite this so that it's so that it's y equals. Is there a relationship between x and y? It has to be x equals, right? I mean, yeah, this distance is either x, but another way to write x is what? Square root of y? And that came from right here. If you resolve y equals x squared with the square root of both sides, you get square root of y is equal to x. Okay, so that's that whole distance though. We don't want the whole distance. We're going to have to take out. We want to take that away. So what's that length? That's y over 2, yeah. So what are we going to square in here? There we go. Both those horizontal distances are x's. I mean, like to describe a horizontal distance, you can use something's x coordinate, but this thing is dy. And that equation allows you to link x and y. So if I know I don't want to put in x into my integral because it's dy, well, just look, is there another way you can express x in terms of y? And the equation is what's going to allow you to do that. So this is our answer for C. We're going to go back real quick and look at these solutions now and make sure we got these right. So this is from, say, 2009 AB number 4. 2009 scoring guidelines. Here we go. Did we have 4/3? Okay. Did we have 4 over pi?
Should we be memorizing
Oops. So,
what cosine pi
yeah, hey, Zeke's got a great question. Should we be like memorizing what cosine of pi is, what sine of pi is? And I'd say yeah. I mean, you have to, so when you think about that unit circle, you better know about, 0, and you better know about pi over 2, and you better know about pi, and you better know about 3 pi over 2. So, just draw that unit circle out. Remember, x is cosine, y is sine. Did we have this one, guys, the last one? All right. Cool. Okay. Well, we'll get that posted up. Yes. Let's see. Okay. Okay. When you look at this diagram, are you alright with that being the length of the square we're concerned with? Okay, so that length is going to come from taking this full length and width and taking away this green piece. And so that full length is the one that's square root y, and the short length is the y over 2.